Buongiorno. Hello, everybody. Here is the title of my talk, The Infinite Game of Vulnerability Research. Please, next slides. Okay.
I can move it for you.
Okay. Oh. So, short introduction. Who is this guy in front of you? I'm David Calligaris. That is my Twitter handle. And I work in Italy for a very long time. I was in a company called the Maze Network that at the moment is acquired by other companies. It's not anymore there. And I was a developer of a security scanner called EP Legion. There are in this room other people that share with me this task. And then I became the CTO. After that, I joined in 2017 Huawei in Germany. And I have two teams. One that is working on fuzzing, and we will talk a lot about that today, and user space and kernel space area. And then I am running the Huawei bug bounty program on mobile phones. So I am the guy that organized this secret conference in Munich a few years ago, where we started and announced the bug bounty program. If you see me around, you can ask me information about bug bounty, fuzzing, whatever. I'm super happy to talk with people working in security. One disclaimer, this is my personal view and don't represent the view of my employee. So what we will talk about today. So the title of the company, The Infinite Game. The Infinite Game is about game theory. And then we will speak about vulnerability research, and we will touch topics like variant analysis, fuzzing, manual code analysis, or manual code review. Game theory. So game theory is the science of decision making. I think you know Russell Crowe, that have nothing to do with game theory, but is the actor that interprets John Nash. I think that John Nash is the most recognizable person for game theory. It's something that pop-ups from John von Neumann. He was playing poker and want to find some mathematical model behind it. And game theory is the science of making decisions. And then a game is defined as the interactions among multiple actors, and the gains of these actors are influence each other. But for a better definition we have there. And then in game theory we have two thinkers, not most on mathematics, but influential thinkers, we can say, that they introduced the topic of finite and infinite games. We have James Cars in '86, and then we have Simon Sinek in 2019. So let's see what is a finite game and an infinite game. So finite games are the most games that we know and we are used it, are played by no players. They have fixed rules. In finite games, we have objects, and when they reach these objects, the game is ended. We are all agree on that. There is a beginning, a middle, and an end. And there is a clear winner and a loser. In finite games, there are all the time new players coming and going in these games, and are played by know and unknown players. There is not a precise agreement on rules. Players can change how they play the game, infinite time horizon, and there is no clear thing what means winning or losing an infinite game. The goal of infinite game is to stay in the game as long as possible. So, for example, business is an example of infinite game. So business born before us and will continue after our life. But I see a lot of analogies with infinite games with vulnerability research. So what is vulnerability research? Vulnerability research is a process that is allowing us to find flaws in software or also hardware, or we will see in the afternoon, that could lead to security issues. And the process is done by static code analysis, dynamic testings, and so on. Who is doing vulnerability research? Internal of your organization, if you have a product, you have people that are doing DAST, SAST, dynamic security testing, static security testing, penetration test teams. And you have also people that are doing vulnerability research out of the company, bug bounty hunters, bad actors, academia, and so on. Why to do vulnerability research? Finding and, of course, patching vulnerabilities is an effective way to make software more secure and making internet a safer place for us, for all of us. And then can be quite remunerative. So here on the screenshots here, we see a company that is offering 100,000 USD dollars for a vulnerability in a chat software, Pigeon. And then below, you see a very, how we can say, curious reply from the maintainer of the software. And the maintainer is saying that he is struggling to have 25K to continue the development of the software for 1 year. And then here we see that a company that is acquiring 0 days is offering 4 times the money for getting a vulnerability in it. So it's a little bit a disequilibrium in that. So let's put together the idea of infinite game with vulnerability research. So we have all the time new vulnerability researchers that join the game, and we have also players playing in the defense. Vulnerability research includes only software, only hardware. We have Spectre, Meltdown, that they open a totally new area. We have the introduction of memory-safe language that kill a lot of vulnerabilities. And this changed how players was playing the game. We have introduction of gray box fuzzing. And then do we know how vulnerability research will end? We have a clear picture in mind. And of course, can we define who is a winner in cybersecurity? Who was the winner of last year? The winner of Pwn 2 Own, the winner of Tianfu Cup. Who is the winner? Who is defining who is a winner or a loser? So let's see a little bit a timeline how this game was played. When vulnerability research, when cybersecurity born, maybe with the first paper or with buffer overflows in the 76, I think, or will be the Morris worm, the worm that was moving from with exploiting a stack buffer overflow on finger on Solaris machine. Or is with the paper smashing the stack for find and profit in 98. And then here we see on the below area the things that are happening in offensive. And in green area, we see the things that are happening in the defensive side. And when I draw this line, I share it with some friends. And we was not agree on a lot of things. So this means that this is an example of infinite game. What we include, friends of mine say, you must include the sandboxing. But why you don't include browsers protections and so on? So the game is expanding, shrinking. They say somebody, why you don't include some specific features that Windows add or another operating system add and so on. So we are not agree, everybody, what is included and so on. And this make a perfect analogy on what is an infinite game. So how is vulnerability research done? We have some emerging techniques that currently are quite used. Variant analysis, fuzzing, and then there is still manual code review. We will do a little drill down on these topics, but after me, you will have 2 amazing speakers. One will speak and go in deep about fuzzing. That is also the area where I'm working. And then we'll have, where is the other speaker? I don't see it in the audience. We'll speak about variant analysis or variant analysis. So how we become aware of vulnerabilities inside our products? We can become aware internal to the organization or external to the organization. We have coding scanning solutions, dynamic testing, internal security teams. We can run honeypots that they catch exploits, and then we can have threat intelligence information. But we have also sources outside the company. So maybe I'm a company, I have my product, I can take a company that is very good in some vertical areas, and we can ask them to perform a pen testing. Or we can have a bug bounty program and we can get vulnerabilities via coordinated or responsible disclosure program. In some cases, they are not optimal, but we can become aware of vulnerabilities in our product via full disclosure, or we discover that they are exploited directly on the wild. So when one of these vulnerabilities reach our organization, we need to set up some project. So first of all, we need to patch the vulnerability. This is something that we need to do to make our software more secure. But then we need to start multiple processes. So how we can prevent similar bugs from happening again? We need to train our developers to don't do that mistakes. We need to change the language. Maybe don't write still code in C, but start to write in Rust, Go, that are memory-safe languages. Or can we kill the vulnerability class? So here there are amazing examples. So around 2008, there was a Cambrian explosion, as somebody will use, of vulnerabilities that are called the null pointer in the Linux kernel. But then the vulnerability was, the total vulnerability class was killed, not allowing any more code execution by not allowing to map the null address from user space and redirect the execution from there. Or, for example, another thing that we do, we can say, oh, if we cannot kill the vulnerability class, can we make the exploitation harder or impossible? But then there is another important question. How we find, so we know that bugs try to repeat, and maybe a developer is making again the same mistakes in other parts of the code. How we can find other variations of the same vulnerability in our project or in other coded bases that this developer is working? Okay, so by variant analysis, we define the process that allows us to find other vulnerabilities using as a seed the no vulnerabilities that we receive from the previous sources. So here there are two examples quite different from each other. And one is somehow geek funny, because the guy says here is in 2021, he grep for. So in 2021, we find vulnerabilities with grep. This must tell us something about what is still cybersecurity. And then in the other article, you see a guy that is saying that he's using a software that is called CodeQL to look at the source code. So let's see how these softwares allow us to find vulnerabilities. Of course, we can use grep, but maybe it's not the most efficient way that we can use for vulnerabilities, but there are new technologies rising on the market that could allow us to find these vulnerabilities. So we start, this is the starting point. We have our source code, and we have our security bugs knowledge that we receive from all the sources that I showed before, and is there from a lot of years, so it's a very huge archive maybe. So we can take our source code, use a parsing engine, and this parsing engine can put our code in a sort of database and put in a special graph representation in it. And we can take our security bugs knowledge, and we can model this security bug knowledge in sort of queries, of templates, that allow us to perform I would say, like a sort of SQL queries in our software and look for variations of the similar vulnerabilities. There are several products that are aiming to do that. There are commercial, open source, and so on. We have very famous CodeQL, we have SamGrep, we have Coccinelle, we have Google Project Zero Wegley, we have Shift Left Yearn, and so on. And it's from what I read and what I'm doing is a quite effective way to identify vulnerabilities. Fuzzing. So what is fuzzing? So we can write the definition here, but I like more explain it as I will explain to my grandparents. So let's see, I think that several people of you one day opened by mistake a PDF file with Notepad, and then you see a random bunch of characters. And then what happens if you take these characters that you see in Notepad, you change it, and you open again it with the PDF editor? Actually, you are performing a super primitive way of fuzzing. It's not efficient and so on, but if you take this Notepad file, you change the data inside, and you open again the file, and the viewer that you are using is crashing, you find a bug. And there are chances that this is a security bug. So doing this manually is not quite effective, but we can automate. So here we have a pseudocode of what a fuzzer looks like. We have an engine, in this case, our while, and then we have our mutator. We can take the corpus, change the file, and corpus, I mean, is the initial archive of files that we have. We can pass the file to our software under test, and if the software under test crash, we have a crash detector, and they say, oh, inspect it, and see if this is a bug. So this is how fuzzing works. Do you think this way is effective, or it's too primitive? Who thinks this is effective? Some hands up. Oh, thank you. Okay, next. It's extremely effective. So here we have several security researchers that are saying that they are using it and integrating in their vulnerability research lifecycle. And then we have several research also from Google Project Zero that are saying that they are using fuzzing to find bugs. And to prove that, not just to be biased by an opinion because we like it, there is a project from Google that is called Google OSS Fuzz that identify more 30,000 bugs in 500 open source projects. Just a note, because sometimes I speak about fuzzing and I see people confuse it because they come to me and say, oh, I fuzz too, and I have a long list of directories for web servers. This thing have the same word at the moment on internet, but there are two different things. This thing is called, in my opinion, directory brute forcing of web server enumeration. So we are not talking about this type of fuzzing. Next. So here are some fuzzing concepts that I want to introduce because will help to understand the things later. So in this diagram, we have something that is the evolution of fuzzers. So we started black box as we done that before. We changed the file without any particular logic and so on. And then we have two branches that fuzzing take in the last years. We have grammar or format fuzzing that was using the format of the file and the binary structures to the file to provide good inputs, very well formatted. Or we have feedback-driven fuzzer and then the use of sanitizers that allows to detect memory violations in a better way. And now we see a merge of these two approaches. And then maybe you heard me speaking a lot of time about harness. The harness, if you see the three pieces of the puzzle there, is the piece of software that allows to connect the fuzzing engine with your software under test. So you remember this slide at the beginning when we speak about variant analysis. So here we have some questions that we need to do. We need to patch the vulnerability. We need to perform variant analysis to find other things. But in my opinion, there is another question that we should add in our SDLC process. Why our fuzzers didn't find the same vulnerability that we receive from the other sources? And here I want to introduce a project that is called Vulnerability Rediscovery, that is, I can say, quite well explained by Live Overflow in his YouTube streams. But basically, when we receive in the bug bounty program, let's say, a memory corruption vulnerability in the parsing of some image file or some other binary structure or whatever, why our fuzzing farm didn't find it? We didn't write the harness. We didn't use a very good set of initial inputs, maybe a good set of PDF files. We don't mutate in the correct way. We don't use the sanitizer, so the thing that allows us to catch memory corruptions and so on. And most important of all is, do we have other parts of our code where I did not, I used the term tame our fuzzer correctly, where I didn't instruct my fuzzer to do the same thing. And maybe I'm working on both on client and server in parsing a data structure, why I must maybe do the same checks also to the other side. I want to introduce other two topics, but here I need a little bit of interactions because everybody is sleeping at the moment. And so this is a URL, and I think this is the best way to explain what is differential analysis, and then we will see how differential analysis can be used also for fuzzing. So what is the IP address that this URL, this input will make our browser, our software to connect? Is 1111.2222.3333. Some options, some interactions, please, be alive. Who is saying 111? How many hands in up? 1, 2, 3, 4, okay, more. We say 2222. Okay, less. 3333. Who say none? Who say something different? All of them in the same time. Okay, good idea. So this is the result. So depends on the library that you use, you have different behaviors. And I mean, the same Python libraries. So in the same programming language. So these are three very popular Python libraries. And when you pass it, so let's say that, I don't know, in the front end, you use one Python library, in the back end, you use another Python library, or in different parts of the code for some needs, you use different Python libraries. And you have different outcomes. And this is what is differential analysis. So you take the same input, and then you use different softwares to see if they treat the same input in the same way. And this is a perfect case study for combining fuzzing with it. And so we see, for example, now there is a proposal to introduce this test in the Linux kernel to see the different implementations in the syscalls. And who is investing in crypto here? Ah, come on, alive a little bit. So differential fuzzing is quite used to test different crypto protocols for the consensus and for finding bugs. And then to see that is an effective way, there is an article of, I think, few weeks, no, 1 month ago, I think, more or less, 23 September, that is from Google Tag, that they got that a group of bad actors was using was exploiting how two different certificate parsers was treating a certificate, and this allowed them to bypass some protections. So I think that the differential fuzzing will be something that we will see growing in the next years, especially, so now we examine fuzzing, especially for memory corruptions vulnerabilities, but we have languages like Go, Rust, and so on, that are not subject of memory corruptions, but you still use fuzzing to spot bugs. And I think is a very good thing that language starts to born with fuzzing capabilities from the beginning. And then there is another trend that we see that is fuzz-driven development, so that you need to write your code that is more easy to perform fuzzing. Manual code review is one of the last points. So by discussing with several security researchers, they say that oh, how you find bugs. So I speak with guys that was working at Pwn2Own competition or something like that. And I ask them, how you find vulnerabilities, what you do. You are participating to Pwn2Own, so you must be good. What is your opinion on that? And for them, and also for me, one of the best way to find vulnerabilities is manual code analysis. Seems very old, but is still one of the most effective to find bugs, especially because it brings novelty. There are some researchers, and here we have different opinions, I think also in the audience, that says that fuzzing and variant analysis allow to find only two types of bugs. Low-hanging fruit, so bugs that are super easy to catch, or hard to spot vulnerabilities. I don't know, a memory corruption in V8 that can be found just with hours of fuzzing. And we need to think about a fact that fuzzing and variant analysis must not be a replacement of manual analysis. Must be a tool that supports our manual analysis to get it better. I think this is a tweet that I really like, and is about a guy that is very famous on the fuzzing scene, and says that automation is the result of understanding automatable problem. So if you never do the manual work, it's very hard to identify what you need to automate. So I think that still a key for innovation, research, and to progress in this infinite game should be still manual code review. Are we with time, Marco? Okay, perfect. I have even less. I am almost on the last slides. Okay, conclusions. So, as you know, I am a manager, and if I don't have a slide with this airplane, you don't prove that you are a manager. So, it's mandatory. So when you become a manager, there is a friend that says, if you give a keynote, you are a security researcher that is playing golf or is close to retirement. So I hope not, but yeah, I need to include a management slide at the end to understand it. So I think everybody knows what is this airplane. This is the emblem of survivorship bias. So during World War II, they start to collect data on the planes that was coming back to the bases and where they receive bullets, and say, oh, look, all the planes that come back to the base, they have bullets in these and these and these and these parts. We should enforce these parts and we should make them more robust. But there was a mistake in this analysis. Was the planes that was coming back to the base. So means that these planes was actually good because they survived. They didn't have the data of the planes that was destroyed. And maybe these planes was the planes that, the hits that these planes receive was in the parts that should be more protected. So what I'm doing now, I speak about variant analysis to use them as a seed and so on. Do we have a survival bias? So we are getting these vulnerabilities and then we find variations. But what are the vulnerabilities that we don't catch? And how we can catch these vulnerabilities that are not catched? How we can avoid a scope bias and finding other vulnerabilities that at the moment are not detected. So I am working with security teams and in research development for many years, and it's not an easy task. So one of the things is that several teams focus on the wrong goals. So they focus on, oh, you must find for the end of the year 10 vulnerabilities in this software. But it's not something that you can control. You don't know how many vulnerabilities you have in the software and so on. But instead, I push my team for something that is called novelty research. So if you are a manager, you are doing pen testing with your team and so on, I really suggest that this book that is about novelty search and is about how to trigger serendipity discoveries in research and development teams. Other thing that I will suggest, if you work for a vendor, don't limit your test with source code, but perform security testing as also backdectors doing. I'm not meaning to do just one, but do both. First of all, engineers like challenges. If you have an engineer and you say to him, oh, you have infinite money, you have infinite time, put this rocket on the moon. Nobody will be got on the moon because they find it not challenging. Say to the guy, oh, you have 1 year to do that. You need to do the rocket super light because we don't have money. You need to do this with these and these restraints. Come on, the engineer is triggered. I want to do that. If you are lacking the requirements and so on, you don't challenge the engineers enough to put the effort on that. And again, don't focus only on automation, but go ahead also for manual code analysis. This is what is trigger innovation, what allows you to push and find new ways to test your software before backdectors are doing. I want to close with this one slide. So I had a lot of discussions about this presentation with friends and so on during beers. And then one guy in the WhatsApp group make a very good comment. And I asked him, can you tweet it and I will put you in the keynote? And he did it. So he has his, follow him on Twitter now. I'm kidding, he's a good friend. And he spotted a very good point that normally inside the company you go, oh, find all the bugs possible and so on, and say instead hackers work in a different way or bad actors work in a different way. They focus on a goal. They want to have RSE, full remote chain on the device and so on. And this allows them to ignore a lot of vulns and then find other things that maybe with the first process are missing. So I think this is the perfect way how you should conduct vulnerability research inside of your team. Apply both methodologies. Think how to kill all the bugs, working on source code and so on, but then add also the methodology that hackers are doing. That's all, guys. Questions?